All right. Well, good morning, everyone. Thanks for joining us today. My name is Nicholas. I'm Director of Customer Success at Hortau, and I'm going to be joined today by Travis, one of our Irrigation Management Advisor. He'll be presenting today and sharing best practices in irrigation management in wine grapes throughout the season and telling us a little bit about our new polymer-based sensor and how that sensor is actually redefining the way that growers will be going about irrigation management, especially in the wine grape industry, and how that new sensor is allowing us to see things that no one was ever able to see before. So without further ado, I'll pass the mic along to Travis, and I'll let you take it from there.
Hey, thanks, Nick. As Nick mentioned, my name is Travis Goldman. I am the Irrigation Management Advisor for Hortau. In today's webinar, we'll be looking at the new redefining 1K sensor that Hortau's come out with. We're looking at the key benefits as well as a case study in wine grapes at looking at high stress versus regulated stress. At the end, we're going to be opening it up to questions, but feel free if you do have a question. Nick is going to be here to flag me if I need to stop during the webinar to answer anything, but in the chat box, you'll see a Q&A. Please feel free to ask any questions there. For the past 18 years, Hortau has worked as a precision irrigation company. And what we're here to do is we're able to help out with predicting, managing, and optimizing our irrigation management decisions. As far as everyone's familiar with our 3 pillars of agronomy, but without a strong irrigation pillar, we cannot support our pest control or our nutritional program. And where we kind of correlate it in is that we're trying to optimize our irrigation pillar for best management practices. With this new 1K sensor, it's really the ultimate plant stress management tool. It has a huge scale from 0 kPa all the way up to 1,000 kPa, and what it's been able to do is help us out with IPM programs and helping out with optimizing our nutritional program that we're putting in, making sure that it's leveraging the way that we're trying to move the vineyard forward, as far as if we need to help out with plant growth or if we need to truly regulate plant growth. And all of this is really achievable by changing the way that we're irrigating. And this is something that, as far as for farmers, we've been doing this for decades. Now, like we said, we've been around for 18 years, but a majority of those years, we've used a tensiometer that was actually limited to 0 to 80 kPa. Now, for most commodities, this is great. It's right within the wheelhouse, and we've really looked at and refined the way that we're irrigating a lot of commodities, especially in North America. But looking into vines, it's fantastic for new plantings because we know that we can help out with vegetative growth by supporting that vine through 10 to 40 kPa and making sure that we're not causing excessive stress and that we're not getting them too wet where they're not going to go out and actually seek water and not build a supportive platform underneath them with their root zone. This is, working with growers along the Central Coast for the past 6 years, it's been exceptional for our bulk wine market before veraison and as well as for finishing fruit once we're looking at trying to optimize tonnage and making sure that we have the right amount of bricks. But for me, on a standpoint, it had a limited range as far as if I dealt with a field that had high stress, it just got dry. It was outside of that parameter. We were constantly having to maintain that sensor. And it was also difficult, regardless if I was in the premium wine grape market or in the bulk, that once I got to veraison, I didn't really know what was happening because the sensor was limited to 80 kPa. And we knew that we were exceeding that tension threshold. For the past 2 years, I've been very fortunate to work with growers with this new 1K tensiometer that goes all the way up to 1,000 kPa. And with this type of transparency in being able to see everything from early bud swell till dormancy, I can track exactly where the vineyard's at and what needs to be altered for the irrigation decisions. It's maintenance free. I'm not having to go out, put water in the sensor every 3 days because it's ran out of water because it's 107 in Paso and the soil's dried. We're going through veraison and we're trying to lignify growing in, so we don't want the tension to be below 80 kPa. In fact, we really want it to be well above that, and that's something that we'll bring up in the webinar. But overall, for me, it's really redefined how I do my job, and as far as with how I'm interacting with growers and how we're using irrigation to leverage growing vines in North America. Now, how are these tensionometers even being used? Well, what we have is we have 3 soil tension depths, and we're trying to track our lateral water expansion at 12 and 24 inches, and we're trying to track the vertical water movement towards our taproot at 36 inches. That 36-inch sensor is trying to make sure that we're minimizing and eliminating leaching fractions, as well as our 12 and our 24. We're really trying to make sure that that water is moving sideways and getting towards that root zone and making sure that we have an overall healthy wetting pattern, a healthy root zone throughout the whole growing season. Now, this becomes really important because water availability is directly related to soil tension. It's the physical force required to remove water from a soil particle. This is all passive. So when the vine is in a healthy state and it's able to open up stomata and help out with CO2 gas exchange, pick up carbon, and release vapor pressure, this partial pressure of the irrigated soil, it's able to use that suction force through the vascular structure, pick it up, and transpire it out. At this point in time, if water is well within the physiological range of that vine, the vine's going to transpire. We're going to have CO2 gas exchange. We're going to have photosynthesis. This is all uptime. And that's why it's so important to make sure that our soil tension is within a certain range for available water. Now, looking at this is that we know that our nutrition is in solution. And if our nutrition is in solution and the vine has adequate water, we know that that nutrition is going to be picked up through the transpiration system and relocated throughout that vine. By optimizing water, we're actually maximizing our nutritional uptake. At that same point in time, too, we can use available water as a leveraging tool to help out with regulating nutritional uptake by basically regulating water availability. We'll come across that example a little bit later, but we do run into wells that do have high nitrogen content. So if we make water relatively available, we're making nitrogen relatively available, which can be a nightmare for cluster with canopy management. Now, we're going to talk about regulated stress, but what's excessive stress? So when we're starting to shut the vine down, we're shutting down stomata. So once the vine realizes that water is no longer available and it can't afford to lose water and start to lose turgor pressure within the canopy, you'll start to see that the stomata have to shut down. What that happens is basically when the stomata have to shut down, we no longer have CO2 gas exchange, photosynthesis is compromised, and the overall plant function begins to stop. So if we're applying excessive stress, we're actually compromising fruit quality, fruit development, if we're looking at that later part of the stage. If we're in a bit of a pickle where we're running into excessive stress through that early vegetative state, we're going to be hurting canopy. We're going to be hurting cluster development as far as with cell division, cell expansion, or even if we have high stress, which potentially we could have this year because of how dry it's been, we could even run into issues during bloom. Just a little bit on the scale standpoint, at 1,500 kPa, the vine will reach permanent wilting point. So this new 1K sensor goes almost up to the physical threshold where we can start killing plants. We can really hurt them at 1,000 kPa, but we're getting pretty close with as far as this management tool of figuring out a huge scale on where we want to be with farming. Now, looking at that scale, we know that we don't want to be too wet, which is going to be near 0 kPa, where water is relatively available, but the limiting factor and what's going to cause vine stress or just plant stress in general is the lack of oxygen. At that point in time, we're running into limited pore space where there just isn't that balance. But what Hortau has worked with for the past 18 years is finding this comfort zone for specific growing conditions to make sure that we're optimizing our transpiration, we're optimizing our nutritional uptake, and using this as leverage to when to turn water on or when to turn it off. Now, looking at regulated stress or high stress, we're going to be getting out of this quote unquote comfort zone. And this is something that I've been able to use this 1K sensor to help figure out. Now, we're going to have to apply at some point in time plant stress, and that's outside of that comfort zone of that blue band. At that point in time, what we're trying to do is we're trying to regulate water by that being the limiting factor. Oxygen is well present within the soil, and that's where we run into dry soil conditions or drier. I love using this image because what does 0 kPa mean? Whenever I talk with brand new customers and they say, oh, well, my tension's at 0, what does that mean? Well, we've made mud. So we've removed all of the oxygen out of the pore space within the soil, and everything's saturated. At this point in time, during early vegetative state, like this early development, it's a huge limiting factor because what we're having is downtime. Because of the lack of oxygen, we're starting to delay and extend types of development stages, and we'll see that later on in the PowerPoint. Now, kind of to reiterate this comfort zone and what we have is a blue band, so this optimum range for growing conditions for the vines. And what that really means is that there is adequate water availability, so the suction force required to remove water from the soil is within that wheelhouse, that optimum range for that vine to function, to help out with photosynthesis, building cells, and just growing. The reason why that happens is because we're improving transpiration rates. So we're improving nutritional uptake, and we don't have any downtime. So this optimum range is exactly where we want to be during our early vegetative state until we need to use irrigation as leverage to help out with restricting growth through that regulatory stage. Now, if you've used our 80 kPa sensors, this is completely out of our viewing of what we've been able to look at. Now, if I were to talk about stone fruit and I were to look at 500 kPa, it would be tragic. We would see tons of huge adverse things. But when we're dealing with drought tolerant varieties that can scavenge water, and it's still technically within the vine's capability of pulling water from that soil particle, that is a measurement. We have to know that. But over the past 2 years, we've really kind of figured out exactly when salts are starting to precipitate out of solution and starting to collect on these roots. So there's a huge difference between regulated stress, let's say at 500 kPa, which is still pretty high, and then going up 800 kPa, where we're actually starting to lose nutrition. We're starting to see salts start to get pushed out of the soil. That's a redefining way that we're going to help out with vine management, because not all stress is created equal. As far as with this, precision irrigation is a year-round job. That's what I do for a living. What I'm here for is optimizing plant function all the way from basically bud swell through early canopy development, and as well as when we get closer to that stage of where we need to start applying stress, we're going to try to make sure that we're regulating plant stress to make sure that we're not compromising the quality of our fruit and the overall product that we're producing. Now, in today's webinar, we're going to be discussing kind of a case study that I've been working with both bulk and premium wine grapes. In this example, it's a premium wine grape image where we have high stress versus regulated stress. And it's kind of the path, which one are we going to choose? Hopefully we can choose regulated stress and eliminate what we can see on the left. through early vegetative development, I think what I run into in what I consider high stress is actually the lack of oxygen. What I was talking about, getting too close to that 0 kPa range, especially for my younger kind of feeder roots. As the vine starts to go through the vascular rehydration, bud swell, and early vegetative push, water has to be available, but so does oxygen. We see low root activity as far as we're not seeing those ticks, the up and down on the soil tension, as you can see in the regulated side. And we're going to see, when we look at the canopy, we're actually seeing delayed vegetative push. Like I said, there's plenty of water, but the limiting factor is oxygen. When we look at regulated stress, not all tension values are within the blue band with that optimum range, but we're allowing the vine to pick up that water out of that soil profile to hopefully help out with drying up that 24 and that 36-inch root zone. By doing so, we still see aggressive water uptake at 12 inches, and we're minimizing that downtime through that early vegetative state. When we look at the canopy and we look at the vineyard right now, or at that time, the vegetative push was far more advanced and it was extremely uniform. All because we're trying to balance and optimize both water and oxygen at this point in time. So this, as far as same day, different sides of the vineyard, if we look at this, the high stress because of a lack of oxygen, we see this delayed push. But if we look at the regulated side, where it's more within that optimum growing condition for a larger amount of time, we're seeing a lot more leaf development and a lot more leaf push, and it's further advanced. Getting a little bit further into the early vegetative state, it kind of flipped the script. That field that was wet now became a field that was hard to rehydrate. It just started to utilize water a little bit differently because it's just a little bit different soil type compared to the regulated side. And we're starting to see where now that high stress field is having more of its top 24 inches of the soil profile outside that optimum range for transpiration. Is the vine still picking up water out of that? You bet. We're still seeing the ticks, the up and the downs within that range. So yes, water is being transpired, but it's not within the peak range of where we want to be for early vegetative push. If you look at the regulated side, we're still trying to dry out the 24 and the 36-inch root zone. So we're allowing that vine to pick up to 100 kPa before we rehydrate the soil profile. So we're applying a little bit of regulated stress to help out with drying the taproot out, but with still not compromising water uptake and water consumption at 12 inches. Looking at our canopies, you can see that the high stress side is to the second wire. Some vegetative push is to the third, but if you look at the regulated side, we're already starting to see that vegetative push at the third wire and slightly above. Later in to June, same field, we're still seeing a lot of stress on that high side, where if you look at it through our early fertilizer applications during cluster development, you start to see that now our 36-inch root zone is leaving that ideal optimum range. It's dry. We're not getting water there. And as well as with these even larger irrigations, it's really only taking care of that top 12 inches. When we look at the vegetative side of the plant, it's definitely stunted. We're seeing shorter internodes, but where I think it becomes even a bigger factor is now I'm starting to see a larger gap in the fruit development side, where I'm still seeing stuff going through bloom and sending out flowers, and I have other stuff that is sending out basically energy for cell division and cell expansion of the cluster. Looking at our regulated side, still applying a little bit of stress as far as to make sure that we're drying up that 24 and that 36-inch root zone, We're extending that tension now up to 150 kPa before rehydrating. It could be probably still at about 100 at this point in time. But at the same time, when we look at the canopy is healthy. We're seeing good internode length, and we're seeing very uniform fruit development. On the high stress side, it's a well-maintained canopy. I have to say, to me, it looks good as far as it has good airflow. Looking at the regulated side, if you look at that, it's starting to actually utilize that water that's in more of a luxury consumption at 24 and 36 inches. So we're going to have to start to, pump the brakes a little bit more on that side. Whereas if we look at the high stress side, we actually need to be applying more water. Looking at the fruit development on the high stress side, just smaller fruit, still seeing stuff that is going through cell division, still seeing stuff that's going through cell expansion. But when I look at the regulated side, larger fruit, more uniform fruit, more fruit. So when we're looking at getting to the stage of aeration, or what we're trying to do is we're trying to apply enough stress to physically stress the growing ends of our vines to help them out with lignifying, stop sending energy to these growing tips, and get that energy to go to the fruit. This is completely out of the realm of what the HXM80 could do within that 0 to 80 kPa range. When I'm writing irrigation recs 3 years ago, I was digging holes. I was looking at vines. I was looking at tendrils. I was looking at where we were at. But with this tool, I can see that full transparency of where my root zone is and if I need to apply more or less stress. Usually we're applying little short shots of water. Well, sometimes maybe those little short shots of water are exactly what the vine needs, and it actually doesn't even apply no stress. Maybe these short little shots, they don't even get down to 12 inches. It's not even supporting the vine through that stage. With this transparency of that tool going all the way up to 1,000 kPa, we see the full spectrum. So as far as looking at the bulk market and looking at high stress versus regulated stress, what we're trying to do is we're trying to optimize fruit weight, but still allowing that vine to cycle through that available water to help out with brick development from converting acids into sugars. At high stress values, what we're starting to see is that we're seeing reduced fruit weight because of the lack of water. And what ends up happening is that it starts shutting that vine down and minimizes that conversion of acids into sugars. In this example, right here, on the high stress side, we saw a 54% reduction in fruit, and we saw imbalanced fruit. As far as with the winery, they were not happy. It just as far as it's just like picking fruit too early, you're just going to have just poor fruit quality. We'll just leave it at that. If we would have been able to regulate that block and minimize tension and, basically try to keep that tension below 200 kPa, we would have helped out with fruit quality, and we would have re-engaged that root system for that specific variety and that root stock to where it would have helped restart that building block of converting those acids into sugars. If we look at our regulated stress side, in fact, it was really minimal stress, I should say. We're still allowing the tension to get up to 80 kPa. On this side, bricks came in at contract value. They were well balanced, but the contract tonnage was maximized. So if you are well within the parameters of what the winery is going to receive, you want to try to make sure that you're maximizing your tonnage. So knowing that you get within that window. Now, if we were running a little bit light on bricks, what we end up doing is starting to apply more regulated stress, kind of like that 200 kPa window that I kind of mentioned on the high stress side, to try to help out with fruit balance. When we move over to our premium wine grape industry and we start looking at our newer genetics as far as with these drought tolerant rootstocks, they can pull tension all the way up to, I think kind of what we've looked at about 800 kPa. When you get to the kind of that salt parameter, after 800 kPa, you start to see just water loss because of larger soil fractures, pore space starts to open up, and it starts to just, kind of leave the soil profile. You'll see a little bit of tension pull up to kind of that 1,800 kPa range, but it's really minimal. It's more just the physiological aspects of that soil losing that moisture. In this example, as far as what we're trying to do with premium wine grapes is we're trying to spoon feed them till the finish line. So applying 2 hours or applying 3 hours just to keep that vine function going. Not equal parts always have equal results. You have to farm your soil types between your clays and your silts and your loams, maybe even your rockier type of soils. If we regulate stress, we're regulating that development of the vine, which is fine. This is what we're trying to do, but we're trying to help out with brick development by making sure that we're not overfilling that fruit. Now there's the other extreme of high stress. So that, I only give it 2 hours every 3 or 4 days or every other day. Well, if it's not percolating down to 12 inches, it's not supporting the vine, and the vine is no longer going to be doing vine function things, which is converting acids into sugars. And what you'll start to see, especially on these vines of, I only apply a little bit of water. Well, if there's no water available, it really doesn't matter. You're going to see low fruit grade. You're going to see low fruit weight. In this situation, we started to see fruit abortion because it got past that 800 kPa range. Salt started to collect around the roots, and the vines did not like it. Now, if we look at the regulated side, yes, there's high stress in this drought tolerant rootstock between 600 and 800 kPa, but it's below that 800 kPa window where salts are not necessarily as a high pressure. So we're riding that fine line of where water is available for the top 12 inches to support fruit weight in that overall fruit development, but we're not causing a luxury consumption of water, kind of like in the bulk industry, where we'll sometimes run into fruit crowding, botrytis, and rupturing. So on the regulated side, the winery loved the fruit. They said it was exceptional. It's well-balanced fruit. You look at the fruit, I can take pictures of it all day. It had a little bit of crinkle in it, so the winery loved it. They weren't buying a bunch of water, but a well-balanced fruit, optimum bricks. So if you look at high stress with that same type of approach that's being applied to the other side of the field on the regulated side, we have completely different outcomes. So this is where precision irrigation comes into play, of where we would have need to have managed the higher stress side, that different type of soil type with a little bit more water at certain stages to help out with catching up and making sure that it's still producing premium fruit like what had happened on the regulated side. With the sensor being out for the last 2 years, we've seen great customer success and we've seen good feedback. The biggest feedback that we have right now is the tool, in that it's full transparency. You don't lose your data in the middle of the summer. You know the difference between 800 kPa in a field and 200 kPa. It's in that realm of where we can actually measure it, and you can start prioritizing fields based off of stress and where you're trying to drive the vegetative and fruit development of that field. It's helped out with improving IPM practices. What had happened with our old sensor is that it went dry, and the reason why it went dry is because of a lack of available water within the soil. Okay, there's a big difference between being at 200 kPa and providing regulated deficit irrigation to a vine, or being at 700 or 800 kPa where you're starting to see physical damage to the plant, which is going to help out with basically attracting mites. It's lowering that immune system of that vine. It's going to basically desiccate it out, and it's going to be higher susceptible to disease pressure. So this IPM aspect of it is that you're keeping everything in check on your desired results because you're able to measure stuff and regulate stress. It's improved consistency back-to-back years as far as with growers that have been able to use it. And a long-time grower that was using our HXM 80s and moving to the 1000s is that 2019 was actually more of a wet year. 2020, I would consider more of an average year. But using that information to leverage the way that we were going to grow the vine vegetatively, and then on the fruit side, was able to be managed well because of the consistency in the data and how we were trying to leverage that for irrigation decisions. Now, what can we expect in 2021? I'm already writing irrigation schedules for fields because we have dry soil conditions. We haven't received nearly the amount of rain that we've got in the past. And what I'm looking at with growers that don't have available water because they're on district water is that we're dealing with dry soil conditions running into bud swell. So when bud swell comes into play, are we going to have available water to that vine? Is it going to be able to be absorbed into the vascular wood structure? We'll see. As I mentioned, early applications of water. I think we're going to use a lot more water before basically these vines are going to break dormancy because of the lack of rain that we've had this year. We're also going to see a higher irrigation demand. That is not good for low rain years, which means that our aquifers aren't being replenished. I think it's going to be pretty tight with the reservoirs and what's going to be happening. So having a higher irrigation demand doesn't really correlate with what we're going to need. Water quality concerns. So if we know that we don't have as much rain in our reservoirs, we know that we're going to be maybe even forced to have to use wells. Or let's say if we're a well-only type of farm, we're going to see a higher water demand from our neighbors. And I think what's going to happen is that we're going to have to keep salts in solution. And that means making sure that we're not getting to those critical thresholds where salts start to precipitate out, even if we're going through deficit irrigation or we're trying to go through veraison, staying well away from that so we're not damaging our vines permanently because of salts. Minimizing stress below 600 kPa. That's the one thing I would say. If you can make sure that your vines are below 600 kPa throughout the whole growing season, you'll be fine. I think once you start to get past that stage, you're going to start to see damage to the vegetative side of that plant, and you're going to see adverse effects for multiple years. I think it's going to be, everyone talks about efficiency and sustainability. This is where the rubber hits the road. Mandatory high water use efficiency this year. We're going to have limited water use, and we're going to have limited decent water, I would say. We need to eliminate leaching fractions in every irrigation. That goes with not applying just a little extra through our early development stage because, I know it'll take 4, but it feels better if I put 6, 7, or 8 hours on it, or, it works out well with my fertility program. Break up that fertility program. Make sure that you're eliminating leaching fractions. Regulated deficit irrigation. I think that's going to happen in the bulk industry, and it's a traditional thing as far as in the premium wine grape industry, but regulated deficit irrigation is going to have to be hit on point. They simply apply a little bit of extra water in the springtime or maybe early summer isn't going to be there. You're going to have to allow that plant to cycle through that water before rehydrating it. And then optimize spring management plan. I think I've said it in pretty much every bullet point, but optimize that spring management plan. If you can do that, you're going to have a little bit of extra water when it gets hot, when you're going to need it, when it's 111 in Paso, whatever it's going to be. We're running to higher extremes in the summer, and we're going to need to use that to cool the vine. utilize those hours that you'd be putting on a little bit extra in the spring and try to tail those in maybe to late spring, maybe to early summer to help out with fruit development. And also, equal applications of water does not mean equal results. If you have a lighter soil and you know that water is going to percolate well, you need to adjust the way that you're going to run that water. If you have heavier soil, same thing. Maybe you need to apply a little bit more water. You're going to start to run into utilizing more water if you start to apply higher stress to your vines, because you're now, instead of just replenishing what the vines are using, you're now having to work off of evaporative loss and rehydration of that entire soil profile, which is a long way to, it's a hard way to come back and try to manage if you're dealing with excessive drought within your soils. So now we're going to be opening it up to our question section. Nick, do you have any questions?
Yes, sir. We did receive a few questions for the webinar, so I'll go ahead and read them off, and I guess I'll let you answer them.
Sounds good.
All right, so we got the first question from Alex saying, I currently don't have access to district water. How critical is it to refill the profile before bud swell?
Okay, it's a growing concern for a lot of my growers that are on district water. We might be having to tap into the well. If you have a well, make sure to test the well water, see where you're at. On the western side of where I'm at in the San Joaquin Valley, we have a lot of boron in the wells, and I don't want to be applying basically hot material to that early into basically the feeder roots of that vine, because I think it's going to vastly hurt initial push of vegetative growth, as well as salts. If they're within kind of a realm of where it's okay, as far as on your water quality and your analysis, using that to rehydrate the soil before maybe a rain event is going to help out with water percolation, and you can potentially push those salts out with a decent rain event. But I would rather keep the salts in solution, rehydrate that profile for the early vegetative push in that basically the wood absorption of that water. But I would say it's critical as long as you're not putting on stuff that's going to be adverse to what's going to happen to your vines. So I'd be more than happy to talk to you later, Alex. I've got my email on the next slide, so feel free to contact either Nick or I, and we'll be in contact with you with more, maybe a detailed answer.
For sure. Good. So we got another question here from James asking, so basically, North County historically receives 18 to 19 inches of rain over the winter. Knowing that water is going to be limited this year, how is Hortau helping in maximizing water use efficiency?
Okay, that's a great question. Historically, we get these late winter rains, and we help out basically with maintaining a full soil profile and using tension to dictate when we're going to apply water and when we're going to be able to apply fertilizer. In the past, it was the vineyard's still too wet and we need to apply fertilizer. Now we're kind of running into when we're going to actually have to need to irrigate for these areas, and we're using tension. We're using, as far as for when it's on a side that you're going to be running on lighter water availability, you need to use the tool as leverage of you're going to prioritize higher tension fields first over fields that might be a little bit more wet. But I think, Nick, does that answer you think? Okay.
Yeah, for sure.
Went on a little tangent, but same thing. If you have a question, especially in that King City area, please feel free to, like I said, reach out via email. I'd be more than happy to talk to you.
Good. We just got another question too from John asking, how are you determining leaching fraction in wine grapes?
Okay, so at 0 kPa, we're looking at absolute full saturation. So if we're hitting that 0 kPa range, we're tracking the basically the point in time where water is freely flowing gravitationally through that soil profile. We can look at, as far as for leaching hours, the amount of time that soil is at 0 kPa until it comes back to field capacity, which most of your lighter soils are above about basically right around 2.5, 3 kPa. Your heavier soils is right around 2, 1.5. So until it kind of comes back up to that 1.5 kPa range. So determining how many time, or the length of time that we're at 0 kPa, is how we're dictating how much of a leaching fraction that we're providing.
Very good. Perfect. And then I believe we have one more question here from Jeff saying, so can Hortau help with fertilizer applications?
We can. So what I was talking about today is the irrigation management side, but we have a completely other branch of what we do, and that's the automation, where we're integrating the soil tension technology to help out with irrigations and fertigation applications. On the irrigation management side, what I'm trying to do is I'm using the data to dictate how much water I need to apply with that fertilizer, and making sure that that nutrition is available and well within that optimum growing condition for it to be transpired and picked up. I'm trying to, as far as with my fertility program, I'm trying to make sure that my wetting pattern and that whole root zone is within the blue band, making sure that it is available to the vine, there's a good balance of water and nutrition, and then I'm not getting too wet below the blue band where it's going to compromise the ability for that vine to pick it up, as well as potentially cause leaching fractions. On the extreme side of things, which we might run into with our early fertility program, is that we might not have completely rehydrated soils. So if I'm not seeing that water percolate down to 12 inches or down to 24 inches, I know that I need to apply more water to help rehydrate that soil and help out with increasing the surface area of the contact with that material by, re-engaging the whole root zone.
Perfect. All right. Well, I think that answers all the questions we got for today. So I believe this is going to sum it up. And Travis, I want to thank you for taking the time today to join me and everyone here to tell us more about the irrigation management in wine grapes. And sorry, we just got maybe... Oh, we have Ross, who's one of our customers up in Oregon, actually, who just said, I switched to the 1K probes last year before the 2020 growing season. If anyone has any questions, they can reach out directly to him. So thanks, Ross. Nice to have you today with us.
Yeah, thanks, Ross.
So yeah, thanks everyone. So if you guys have any questions, feel free to contact either me or Travis directly, and we'll be happy to answer you. And hopefully this was insightful for you today.
Sounds good.
All right.
Well, thanks, Nick.
Thank you.
Thank you, everyone, for attending. I'll hopefully catch you guys later.
Yep. Thank you, everyone. Bye-bye.